Hello everyone. My name is Vaishnavi Vijay Balkawade. I am a student of the online B.Sc Honors in Data Science and Artificial Intelligence at IIT Guwahati. Now, this video presents my term project 3, which is titled DataCore IQ, an AI assisted data intelligence platform. Now, the objective of this project was to build an unified platform that assists users throughout the complete exploratory data analysis workflow. In practice, data analysis often relies on multiple disconnected tools for uploading datasets, profiling data, cleaning data, and for visualizations, etc. Now, DataCore IQ integrates all of these tasks into one simple application, allowing users to manage their projects, analyze datasets, perform pre-processing operations, and generate interactive visualizations along with AI-generated insights, and export professional analytical reports. Now, coming to the technologies used, Open VS Code VS Code was used for building this platform. The front end of DataCore IQ was developed using React, TypeScript, Tailwind CSS, and Plotly.js for interactive charts. The backend was implemented using FastAPI. The dataset processing and statistical analysis were performed using the Pandas library in Python. Now, AI generated summaries and chart explanations were produced by a locally deployed Ollama network. This network used Llama 3.2 as the language model for interpreting different charts using prompts. Now, professional PDF reports were generated using ReportLab. Project metadata was stored locally in JSON files, while datasets and reports are organized within project-specific directories. Now let's see the implementation of the project. Before going to the implementation, let's quickly go through the workflow of the project. The workflow works like this. The user first enters the application and then either creates or opens a new project. Inside a project, a user can upload multiple data sets. So he uploads a data set. The data set goes through validation and is then stored. Dataset profiling is basically the dataset is analyzed by the system that we have developed and it shows different statistics of the given dataset. Then the user can perform data cleaning as per their own requirement and then visualize different aspects of this dataset. AI analysis is also an option where the user can ask the Llama model that is implemented to explain the given dataset. Then the user goes forward towards PDF generation and the results are displayed on the dashboard and the PDF can be downloaded on the user's device. This is the system's architecture that was implemented. As you can see, the layer 1 is all the front end, which consists of dashboard, dataset workspace, the visualization module, the AI module, as well as the report module. Then coming to the technology that was used for implementing the front end is React, TypeScript, Tailwind CSS, and Plotly.js. Then now this front end interacts through FastAPI. It uses FastAPI to interact with the core backend services, which include project service, dataset service, profiling services, etc. Which also now these backend services interact with the main datasets and the reports, the logs that are generated in the project metadata that is saved. Now let's quickly take a look at the implementation. This is the dashboard. This is the main dashboard. Here the user can create a new project as per their wish. You can see the new project is added here to the dashboard. You can further open this project. This is a quick this is a quick it a visualization that stores like the latest updates on the given project, the number of reports, and the data sets that are included in the workspace. Now the application validates the uploaded file and stores it within the project's dataset directory. After uploading, I can preview the dataset as well. Now let's upload this sample dataset for healthy lifestyle. Now the preview option here displays the first few rows, column names, and detected data types, as you can see here, as well as the overall dataset dimensions are visible in the preview section. Now let's go to the profiling. Now this next stage is an automatic dataset profiling. Here the application computes descriptive statistics and several quality metrics, as you can see here. Here the application computes a quality score. This and the other metrics include the total number of rows, the total number of columns, memory usage, the number of duplicates, number of missing values, numerical values present, categorical values present, as well as date and time values present in the given data set. The profiling model also performs outlier detection using interquartile range method. In addition, recommendations here are provided to assist the users in improving the overall quality of the dataset for further analysis. As you can see, no outliers are detected in the given dataset. This is the missing value analysis where column-wise missing values can be seen here. These are the column profiles which show the mean of the column for numeric values and unique values, etc. The data type of a particular column and all. Now this is where the user can perform the different data cleaning operations as per their own requirement. Now since we have one duplicate value here, I will demonstrate remove duplicates. As you can see, duplicate values are removed here. Now the number of duplicates is 0. Now I will demonstrate first. Let's look at the missing values that are present. As you can see here, there are a few missing values present in the stress level and the healthy lifestyle. Let's select a column and then fill missing values. Since the column is a string column, we cannot apply numeric operations. Hence, we will apply a constant value. Here, constant value, let's say the stress level is low. Here you can apply. Now, as you can see here, the stress level missing value is 0. Now, when we check the preview, the missing value is gone, it's low. Now, DataCore IQ provides multiple such preprocessing options. User can clean datasets without writing code. Now, available operations include removing duplicate records, dropping missing rows, dropping missing columns, and also removing empty columns. Every preprocessing operation then immediately updates the dataset and refreshes the profiling statistics. In addition, all cleaning activities are recorded in the project history, so the users can track what modifications were done by them previously or by anyone else who worked on the same workspace. Now let's take a look at the history. As we can see here, you can see that we removed the duplicate and we filled missing values in the stress level column using the method constant. Now let's go on and check out the visualization option. This is a very interactive feature of the application. As you can see, we can either generate a histogram of sleep hours, shows the sleep hour distribution. Or we can visualize and we can generate a scatter plot, sleep hours versus exercise hours. Now these charts are generated interactively using Plotly. After generating a visualization, the user can request an AI generated explanation as well. Now as you can see, we can visualize multiple charts like histogram, scatter plot, bar plot, line, line chart, box plot, and heat map. Now let's continue with our example of our scatter plot. Instead of simply displaying the chart, the language model also analyzes the chart and provides a concise summary, key observations, and recommendations. Now, as you can see here, the AI insights are generated for the given chart. Here, the insights and the recommendation based on the analysis that the AI provides. Now, there's one more feature where the AI also generates insights on the entire data set. Apart from the chart explanation, these are basically the dataset level insights that the AI generates. Instead of directly providing raw dataset to the language model, the application first computes the verified statistical summaries using the profiling module, and these verified statistics are then supplied to the large language module to reduce the possibility of unsupported conclusions so that the model does not hallucinate. Now, the generated response includes an overall summary and important findings. As you can see, it consists of the summary, the key findings, recommendations, and the readiness of the dataset to apply to machine learning. Different machine learning algorithms are if like how ready the dataset is to apply to other applications. Now coming to report generation. Finally, the platform can also generate a professional analytical report, as you can see. The report combines project information, dataset profiling results, AI generated summaries, recommendations, and the ML readiness into a structured document. Now, this report can be downloaded from the dashboard. As you can see, it's downloaded here. This is the overall report generated. You can see. Okay, now I will briefly explain the project structure. Here, the front end is implemented using React components and TypeScript services. The backend follows a modular FastAPI architecture. Each major functionality has been separated into dedicated service modules, including dataset management, profiling, cleaning, visualization, AI analysis, and report generation. This modular design helped me improve the maintainability of the project and also allows individual components to evolve independently. Now coming to the backend. This is the main dataset service where the function was written to upload the dataset from the particular device and to load the dataset on opening the dashboard, etc. Then coming to project service, this is the main dashboard where different projects get loaded and each project is stores their own data sets, reports, etc. Now coming to profiling service, this is where main the column profiles are calculated, the missing values, outliers, missing columns, etc. As you can see, this is where the quality score is calculated depending on the number of duplicates, the missing values, outliers, etc. This function generates recommendations from the given calculated data. This function analyzes the missing values. This function detects the outliers using interquartile range. And this is the main profile description. Now moving on to the AI service. Now this is the main file where the AI Llama model was given prompts. As you can see, this is the dataset AI Insight prompt where this was the prompt given to the Llama 3.2 model to generate data AI insights. Now coming to report service, this is where the PDF was formatted and including all the insights, statistics, etc. This is where the report is generated. Okay, now since this project is a software engineering application rather than a predictive machine learning model, traditional evaluation metrics such as accuracy or F1 score are not directly applicable. Instead, functionality was evaluated by testing every module independently. The application successfully supports project management, data set upload, profiling, pre-processing, visualization, AI-assisted analysis, and automated report generation. Now, multiple datasets in different supported formats were tested, like as you can see, CSV, XLSX, XLS, TSV, JSON, and Parquet. These are the different supported formats of datasets that can be used to and were verified with correct operation of implemented features. Now, coming to the limitations, although the application provides a complete exploratory data analysis, there are a few limitations. Currently, the dataset comparison, we cannot compare different datasets with among themselves, and collaborative project management has not been implemented yet. Also, the AI generated insight also depend on the quality of the computed profiling statistics and should assist rather than replace expert interpretation. Coming to the conclusion, to conclude, DataCore IQ integrates project management, dataset exploration, pre-processing, visualization, AI-assisted analysis, and automated reporting into a single application. Now, developing this project provided valuable experience in full stack development, data pre-processing, REST API design, interactive visualization, and local large model integration. In future work, I plan to extend the application by supportive dataset comparison, collaborating projects, advanced pre-processing operations, and additional AI-assisted analytical capacities. Thank you so much for watching. This was my project DataCore IQ.